Hello, come on in. Find an empty table. That one's fine. We just started, so we haven't done anything yet. Okay, so this is MTE 250. You guys are all in the bachelor's math program with teaching certificate. Is that right? Great. Okay. And so this is technology and visualization in the classroom. And so here, the syllabus is posted on Canvas. And here it is. There is a quiz next Tuesday as part of your assignment on this course description. So let's talk through this. So this course is called Technology and Mathematical Visualization. However, it's really a course for people who want to gain insight into mathematical thinking. Is it big enough for you to see in the back? Okay. Gain insight into mathematical thinking, learn how to make a quest for insight your way of learning mathematics, and help mathematical learners gain insight into mathematics and learning. Okay, so technology can play a vital role in 3 quests. So the first is you can create visualizations that provide talking points for your own thinking and for discussions with students in the classroom. And so we're using visualizations to help us teach. So they give us like an object around which we can talk and have discussion and have a series of questions and learn something. Second role is you can clarify your own thinking as you design visualizations to convey your thinking. So as you're building visualizations, that takes mathematics. That takes understanding mathematics. And so you'll often reveal your deficiencies or stumbling blocks, and then getting over those humps like helps you to understand better, clarifying your own thinking. Okay, and then you can provide your students opportunities to gain insight by sharing your visualizations and having them analyze them, or have them create their own visualizations. Okay, and so really these are really about this software that we're going to use called Graphing Calculator, GC. That's going to be a big part of this course is learning to build visualizations in GC. And so, like this last one says, if you have a visualization, you can share it with students and have them analyze and figure it out, and that's a great exercise, but then also have them build their own visualizations. And that's actually, that's what we're doing in calculus. At ASU, there's a calculus called Th Aug calculus. And Th Aug calculus stands for developing and investigating a rigorous approach to conceptual calculus. And so that is about helping students to see kind of the meanings behind calculus. And so in those courses here at ASU, MAT 270, students have a copy of GC just like you will, and they're building some files and doing homework questions that require GC. And so just like this is saying, we're trying the students to do that. And so this course, a big chunk of this course, will be going through the Th Aug calculus, but from a teacher's perspective, you're going to actually be building the visualizations that us as instructors are using in that class. Does that make sense? So the students, they have their own, in 270, have their own level, kind of a lower level of things homework that they're doing to understand the calculus. Then there's more advanced visualizations that the instructors are using. You guys are going to build those. Okay, so we're going to get up to speed to get up to this point where you're going to be building much more sophisticated things. And all the more, they require understanding and knowledge of the calculus. Okay, so that's really cool. So you'll be very proud of yourself halfway through in the course when you're building these very sophisticated animations. Okay, which we are using currently at ASU to teach calculus with as objects, talking points. Okay, so in this course, you'll learn to use graphics software to investigate mathematics. That's this GC I'm talking about. Other programs, okay? And then all of it's to design learning opportunities for students. Okay, so here's an important thing. Why a big deal about technology enhancing, about it being for you, right? So isn't this supposed to be a math ed course where we're talking about, so there's a lot of this about you gaining understanding and developing understanding. So what's the big deal about that? So your mathematical understandings are a major determinant of your students' understandings, okay? And your attitude towards making sense of the mathematics is a major determinant of your students' attitudes. So when you think about you as a future teacher, what do you think has the greatest impact on you as a future math teacher? What will determine the way that you teach more than any other thing? Anybody, including Richard and Angel. What do you think is the greatest determinant of the kind of teacher that you're going to be? And that's not a quiz from looking at the syllabus.
Oh, yeah, like, I'm to answer.
Is that you, Richard? You're kind of broken up there.
Oh, hello. I was just trying to say, like, our exuberance towards the subject, if we feel engaged, then it would our students.
But what I'm saying is, my question is, the way that you, Richard, and the other students, the way you guys are going to teach in the classroom, what's going to determine what that looks like? What's from your, from everything from being born up till when you're going to teach your first math class, what do you think what's going to have the greatest influence on how the kind of teacher that you're like? Yeah, like your own teachers, right? Like your whole high school and college career. That's the expectation, that you're going to teach like they did, right? So in the same way, so we want to have the optimum situation so that we're passing along, understanding to our own students. Okay. All right, so we're going to download and install a graphing calculator. See Canvas announcements. GeoGebra we may or may not get to. Really, so GC is really the main thing here, and that's also part of your homework for next Tuesday. So studying for the quiz, which comes from these bullet points that I've just talked through, downloading GC, and then the other thing for next week, you have an assignment due a week from today, and that's called a critical précis. So let's go to no. Okay, here we go. Hello.
Hey, what time is the class over here?
1:15. Over?
Great, thank you.
Yeah. So here's what Canvas looks like right now. So here's the announcement for how to download GC if you haven't already. Okay. And the syllabus is posted. And you have 2 assignments, and this is the summary for what's due coming up. Download GC, read the syllabus, be ready for the quiz, and then get starting on the critical précis. And the critical précis is basically a Reader's Digest version of another article. So you're going to read that article, and you're going to condense it down and kind of write a shorter paper that hits all the main points. Okay? And so here's some information about that. There's no analysis, reflection, or opinions from you. It's just a rewrite of the article in a shortened form. Does that make sense? So the longer that the article is, the longer that the précis will be. Okay? So there's no like set, it's not always 2 pages or something like this, right? So if you have a very long article, then to summarize it well, it's going to take a longer critical précis. Okay. So think of it as a long summary or synopsis of the article. Submit a hard copy this is not true. You're going to submit everything online. So there will be a place that, yeah, submit assignment. So in the wherever you find the instructions for assignment, if you're submitting something written, then that's the place to submit it as well. As a general guideline, 2 pages would be too short, 10 pages would be too long. That's just a very general guideline. Like I said, if it's a longer article, it's going to need to be a longer précis, okay? And then in addition to writing the critical précis, answer these questions, which is more analysis and reflection on the article, okay? So that'll be due next Thursday. And there'll be an assignment from Tuesday to Thursday also, a GC, like more mathematical assignment. So you don't want to save this for just one night before, okay? So do work on this weekend. Definitely read the article, read it a couple times, and maybe start writing. And if you have questions about it, come Tuesday. But don't put this off till the last couple days, because there's also going to be homework, new homework for Thursday that's assigned on Tuesday, okay? So questions on that, critical précis. So that's assignments. Anybody have a question about upcoming assignments or what the critical précis? There's nothing to submit. That's just a bullet point list. You're downloading GC on your computer, and then you're gonna have a syllabus quiz. On Tuesday. Yeah, we'll take a quiz on that syllabus, just a real short quiz on Tuesday. Yep. Okay. Angel and Richard, you guys still with me?
Yeah.
Okay, very good. Okay. So let's, so people. So so you guys can call me Mark. I'm Mark Ashbrook. I've been teaching at ASU since 2000, so 20 years. This is the first time I've ever taught with a mask on my face. So I guess it's going okay. My ears kind of hurt a little bit. These masks are a little too tight, but hey, you know. And I've taught this course, so taught calculus lots and lots here, and I've actually helped get Dirac up and off the ground about 8 years ago. We started the Dirac calculus and got that off the ground. And then I started teaching this course maybe around the same time, 8 to 10 years ago. And then since I've been teaching this course, I've kind of brought more and more of the Dirac into it, because I thought we're using all these great animations in Dirac that force us to understand the calculus. Would be perfect for this class to really be working through it also and at a deeper level. So having to make those animations yourself. Yeah, so that's me. And then let's see here. Is there an attendance? So I'm safe to open up the grades here because there's no grades in there yet. But I just want to, that's not, it's leave student view. So now there should be attendance somewhere. Oh, here we go. So Richard and Angel are here. So where is Ashley? Ashley's back there. Okay, great. And Elizabeth, I think you had me for just Calc 3. Okay. And I tried to, so Calc 3 is kind of a hybrid of traditional and the Dirac calculus. Did you have Dirac calculus here? No. You didn't. Okay. Well, you're gonna get it now. And Calc 3, the way I teach Calc 3 is I try to inject as much conceptual as I can into it. And Sarah is here. And I had you before for which one? Calc 3. Okay. And then Donna is here. Donna, Sarah, Elizabeth, and you go by Elizabeth. And then Ashley, and so this must be Yosra. Did I say it right, Yosra? So I did get your email, but I wasn't able to send back. Did you? They're all coming back to me. Okay, so you're good. Okay. All right. Yeah, it's because I couldn't reach you because it seemed like your emails were bouncing back to me. Okay, so we're all here. So let's do a little math today, and so let's talk about. Well, no, before we do that. Let me show you a fun video. So this is my daughter. I have 2 kids, Emma and Samuel. This is Emma, and this is from, oh geez, 6 years ago, I think.
Emma, where's your fork? Where's your fork?
Can you hear that?
Emma, what happened to your fork?
Emma, where's your fork? Emma, what are you eating for dinner? Pasta, is it good? What are you using to eat the pasta?
A fork?
A fork, yeah. Where's your fork?
Did you see it? It was there the whole time.
There it is.
Was that funny?
Can you show us how you can use your fork? Can you show us how you know how to use a fork? Very good.
Remember how Grandma showed you?
Keep it up. That way, that's right.
I wanted to show you. So, did you see it the whole time? It was there. It was there the whole time. All right, and then here's the fun one. This is my son.
Emma, where's your fork? Where's your fork?
There it is. It's sitting right there. Okay, so they are much older now. So here is, this was this summer. We just got a new puppy. Wait a sec. How did I do this? There we go. So this is from May. This is when we got our dog May, in May.
Okay, ready? Here we go. Let's take a picture. What happened to your cheek? Should we go?
Yes!
Samuel, is it time to go?
Yes!
How many seconds do I have?
19, 18, 17, 16, 15.
Okay, so those are my kids. All right, that's fun. Okay, so I want to show you this. So we're going to start talking about some math here. And so this is from what is this from? The 2009 Berlin something competition for running. Okay, let's watch this. So we're going to start talking about some math here.
Paul ist der schnellste aus den Blöcken. Jetzt kommt er. Und jetzt ist Usain Bolt nicht zu halten. Nein, er gewinnt. 9,58 Weltrekord. Ein Wahnsinn.
Okay, so you may be familiar with Usain Bolt. He's kind of fast. He's faster than me. And he's faster than everyone pretty much. So he ran 100 meters in, what, 9.58 seconds. So my question is to you, how fast did he run? If he ran 100 meters in 9.58 seconds, how fast did he run? Use of electronic devices is permitted. How fast did he run? If he ran 100 meters in 9.58 seconds, how fast did he run? And then what? Well, tell me more. I mean, so 100. Why did you do 100 divided by 9.58?
Trying to figure out miles per hour, but that's not an hour. But I don't think he was going the same speed throughout the whole thing.
Okay. So, all right. What about you, Elizabeth? What did you do?
Well, I did a bit of dividing it by eight
Okay.
just to do like meters per second.
Meters per second.
Average. So
Okay.
average.
Average speed. Okay. Is that the rest of you did? And what did you get for a number for that?
I got
10.44 meters per second. Did the rest of you get that? Okay. So, so yeah, Usain Bolt broke the all-time world record, or he set, I should say set, the all-time world record because it still holds today. In the 100-meter dash with a time of 9.58 seconds. What was the speed? And so you calculate 10.44 meters per second. So what, and so here is I got distance time data for his race, like how far he was at different periods of time, and I modeled that to a curve, and then I recreated his race. So this is actually kind of pretty accurate to how his race went, like this. And this is GC, all right? So this is graphing calculator, and so I've created this animation to help us have a conversation about speed. Is there what? It's just
in the middle.
yeah. Yeah, yes, that wasn't reproducing his race. Exactly. That was a technology glitch. Maybe let's see if it doesn't happens here. But that was a good one. That was a smooth one. All right, so we got this number, 10.44 meters per second. And so Yasra brought up a good point that does he always go the same speed in the race, or does he go different speeds? He builds up, right? So it's impossible to be going 0 and then suddenly be going another speed. That's impossible. You would die, okay? Because an instant acceleration to go from 0 to even 1 mile per hour means that's like instant acceleration, which means an infinite amount of force. So it would just crush you. You have to speed up. You have to speed up. And so you can see that he's speeding up. So how many different speeds does he travel throughout the race? Okay, how many? An infinite number of speeds, right? So if he's going from 0 up to his top speed, is 10.44 his top speed? No? Okay, so then there's even higher speeds that he's going than 10.44. So he's covering an infinite number of speeds throughout this race because the speed is changing, right? But yet, when I asked you how fast did he go, you gave me one number, right? So what does that number mean? Someone said average speed. Okay, well, what's that? What does that mean? What is average speed? Oh, and so by the way, we're going to be doing, so GC is going to be, it's computer software. So you're going to bring your laptop. Everyone has a laptop, right? If you don't, we'll talk about it, but download GC on your laptop, bring your laptop to class every time, okay? So we'll work on that in a second, but any thoughts? So that goes for you guys too, Angel and Richard. What do you think this number 10.44 meters per second, what does it mean relative to Usain Bolt's race? Okay, so every second that goes by, he travels about 10.44 meters. Agree with that? Is that true for the first second? Probably not even more close to 10.44 meters in the first second, right? So, okay, that's good idea, but probably we want to try to think of some other ways to explain this number, 10.44 meters per second.
Constant speed, he would have to travel the same distance in that period of time.
She said the constant speed that he would have to travel to go the same distance in the same amount of time. All right, I have a new, so. I have a new aspect to my animation here. It's Emma. There she goes. Go, Emma. You can do it. You can beat the world's fastest man. Oh, come on. It's a tie. All right, maybe the next time. Maybe she can get it. Here we go. So Angel and Richard, I handed out a piece of worksheet, which is on Canvas in modules and like class worksheets. So you guys should go to that. Are you still with me?
Yeah.
Okay, yeah, so go to modules, class worksheets, and I just handed out that one worksheet that's posted there. Okay, so I added Emma into this animation. So let's look at the questions. Now we're ready for these questions. Okay, so what distance did Usain travel and what distance did Emma travel? Yeah, they both traveled 100 meters, right? That was an easy one. Okay, how many seconds did it take for Usain to travel this distance? 9.58 seconds, right? What about Emma? Same, right? Okay, then what's the difference? Emma's speed is constant, right? So that's kind of the point of me putting Emma in there. So Emma is running at a constant speed so that what occurs? So what constant speed is Emma running?
10.44 meters per second.
Oh, is that Angel?
Oh, yeah.
Angel said 10.44 meters per second, right? So this is question number 4. Our focus here is on Usain and his speed, right? I asked you how fast is Usain running, right? And then we calculated this number, 10.44 meters per second. Okay. So then what's the purpose of Emma and the animation? How does it help us understand Usain's race? That's so our focus on Usain and his speed. So why is Emma there? How is it helping us understand Usain's speed?
I think it gives a reference point to tell when to maybe clear when he's like speeding up.
Okay. So yeah, as you can, it kind of helps you see his different speeds throughout the race. What are those two? Ashley, is it Ashley? Any idea? So why did I put Emma in here? If our focus is on Usain and understanding this 10.44, then why is Emma in there? How does she help? Good, excellent. Yeah, so it's showing, right? So it's showing that this 10.44 meters per second, is that a changing speed or a constant speed? That's constant, right? So this number that we got is really, it's one speed, so it's a constant speed. And so Emma is illustrating that. Is illustrating the constant speed. And which constant speed is it? So now we're talking about Usain. What constant speed is Emma running? The constant speed that? Right, good. So it's this constant speed to achieve the same distance in the same amount of time. So that's what that number means. That's what that number means. When you have something traveling at many different speeds and you calculate this one number, just distance divided by time, you're finding the constant speed, like Donna, right? Donna said earlier, you're finding the constant speed to travel the same distance in the same amount of time. That's what average speed means. It's not add up a bunch of speeds and divide by the number of speeds, right? We can't do that. There's an infinite number of speeds. We kind of can. We could do that with an integral, but still, that's not the way we want to think about it. We want to think about, we're going to get the equivalent constant speed, the constant speed to go the same distance in the same amount of time. And that's, so Emma is showing that constant speed to help us understand what this number means for Usain. Okay, any questions or comments on that? Does that make sense? Okay, so if average speed is a constant speed, let's make sense of constant speed. Okay, so what is constant speed? That's part 2 in the worksheet. Did you guys both find the worksheet?
Yeah.
Yes.
Awesome. Okay, so we're going to move to part 2 on that worksheet. And it says, suppose you are driving on a flat highway with a cruise control at 70 miles per hour. So what is the mean? Let's do one together, and then we'll break up and do the number 2 separately. But what is the meaning of the constant speed, 70 miles per hour? Or maybe if you've delved into this principle of constant speed in other classes here, maybe how would the average person answer this question? What is the meaning of 70 miles per hour? How would you answer that? Just a person on the street. What does 70 miles per hour mean? Going 70 miles per hour.
For every 1 hour, you go 70 miles.
Right. Isn't that the common definition, right? So it just means if you're going at this speed, then in an hour, you're going to cover 70 miles, right? Every time you go for an hour, you're going to go 70 miles. Okay, so that's kind of we actually want to develop there's a better definition. So that's a true statement, and it's okay. There's nothing wrong with it. But for the purpose of calculus, we want to understand constant speed a little more broadly and generally. So I want you to work on number 2 and 3. So everyone work on 2 and 3 by yourself. And see if that leads you to think any differently about the meaning of the constant speed 70 miles per hour. Okay, so let's see how we did on this. Sarah, did you make some progress on 2A? Okay, tell me. So 140 miles at 2 hours, okay.
And
350 miles for 5 hours. 35 miles traveling for half an hour. 7 miles for 110. Agree with that? Okay, so then Sarah, keep going. Based on how you answered the questions above, how far would you travel in X hours? 70 times X miles, she said. Agree with that? That's agrees. Elizabeth agrees. Ashley, agree with that? Okay, yeah. So in X hours, you travel 70 times X miles. Richard and Angel, you agree with that?
Yeah.
Yes.
Okay, so let's see. So considering those answers, especially 2B. So considering that answer to 2B, what's a more broad and general meaning for the constant speed? So what did we say? We said every hour you go 70 miles. But now we just realized that what? In X hours, you go 70 times X miles. That tells you a lot more than just every hour you go 70 miles. So who summarized that in number 3? Anyone volunteer? Elizabeth, did you write something for number 3? Okay. Yeah. That's true. Okay, so it's a good start. So, so it's not. We know that you're going 70 miles per hour, but what did we find for any time X? What did we find out? Like yeah. So how far you go is how far, Elizabeth? 70x miles, right? Yeah, so here's the deal about constant speed. It tells you a lot more than how far you go in 1 unit of time. It tells you how far you go in any amount of time, right? That's a much broader definition. So given any change, any variation in time, and we'll call it, so you call it like dt, okay? So we could say dt. Some notation going here. So given any variation, what's this now? Given any variation in time dt, your change in distance, so you say d equals what? How can you get the change in distance for any given variation in time? Yes, or what do you think? So given any variation in time, how can we, at 70 miles per hour, how can we get the corresponding variation in distance? Right. So do you see how that's like a much broader general definition than just every hour you go 70 miles? Really, you know, at that speed, you know how far you go in any amount of time. So we call that dt, and you'll multiply that by 70, and that'll give you how far you go, or the variation in distance. So Angel and Richard, how are you seeing my pen moving around here on the screen?
Yeah.
Yes.
And you can see what I just wrote there?
Yes.
Good, sweet. Okay, cool. So I want you to practice. Look at number 4. There's another constant right there, $2.10 per gallon. That's an example of a constant rate of change. Okay? And I think it's a little low right now, like 230, 240 right now. But anyway, $2.10 a gallon. Explain the meaning of this value in a broad and general way, like we just learned. Okay? So can everyone write it out? We want a meaning that's broad and general for this constant rate of change of $2.10 per gallon. And then maybe a few examples. But everyone write out a statement based on what we just learned. Okay, any volunteers? How did you answer number 4? I want to share what you wrote. Yeah, that's right. Okay, she said, given any variation in gallons, the cost of the gasoline will be 210 times that variation in gallons. Okay, Elizabeth likes it. What about the rest of you? Agree? Yeah, good. Yeah, so, and that's exactly how it works when you're pumping gas, right? You can pump 0.3 of a gallon. You can pump 0.9 of a gallon, 11.6 gallons, 19.8 gallons, and it's gonna. How does it tell you how much you pay? How much it costs you? What does it do? How does the pump calculate your cost for the gas? Yeah, it's going to be that constant rate, 210. So it'd be 210 times however many gallons you put in. Okay, so the fact that gallon costs $2.10, costs $2.10 a gallon, means it knows what your cost will be for any amount of gas that you put in your tank, not just 1 gallon. Right? Okay, very good. So let's put this to work here. So any questions? Anybody? Any question? All right, so average speed. What is average speed and what is constant speed? Average speed is? I paused it here so that I could show you that my daughter can run 9.5 meters faster than Usain Bolt. Do that. She's still ahead. I'm proud of her. So Average speed, what do we find out? Average speed is what? The constant speed to go? What was average speed again? Constant speed?
Same distance.
Right, it's the constant speed to cover the same distance in the same amount of time as your moving object in question, right? And then what is constant speed then? Constant speed is about knowing how much change you have for any change in your independent variable, not just one unit of change in your independent variable. All right, so flip over to part three. So it says, suppose you open your laptop during a class to take notes. 35 minutes after class started, your laptop has a 41% charge. 75 minutes after the class has started, the battery has a 28% charge. The percent charge P, that'll be our dependence, changes at a constant rate with respect to the number of minutes since class began. Little t independent. So first thing we want to do is find the value of the constant rate of change of that percent charge with respect to time. Okay, so I guess some of you have made some progress on that. I want to show you. So this is a GC file that I've created to help us with the discussion that we just had, and so it's somewhat sophisticated, right? So there's some mathematics behind this. What's going on? So I'm gonna open a new GC file. So when you get a new GC file, it looks like that. And there are math lines. Math lines start with a colored square right there. And that will refer to the color. If you end up graphing something, that's the color of the points that you graph, okay? But then math lines can also just be used for computation. So I want GC we want to set up an expression here to calculate the constant rate of change. So how about Richard? Were you able to calculate the constant rate of change? And so tell me what I should type in to do that.
Yes. I did fraction. Do I have to tell you fraction ahead of time?
Okay.
Or?
Sure. I'll just start with the numerator. Okay.
Okay. And the numerator was 35 minus 41.
Okay.
The denominator was 75 minus 35.
Let me make it bigger here.
Oh, wait. Oh, I misread the value. Sorry. The first 35 in the numerator should be a 28.
28. Okay. Very good.
Yes.
Do I have it right now?
And that was it.
So do you guys agree with what Richard did? The answer is yes. Sarah, Ashley. Okay. Everyone's nodding. Okay. So here's the constant rate of change. And it's negative 0.325. And so notice, so in GC, and I just want to show you a few little things about it today, but next week we'll really start digging into learning about GC. But it's basically a calculator. You put the mathematics in, it interprets and gives you something back. Now, in this case, it's giving us back a value for a numerical expression. Okay. As soon, I can put pi in there. And as soon as I update to be 28 pi minus 41 over 75, then it updates the current value of the expression. So it's as long as there's a valid expression there, this will always be updated to the current value. But I don't want pi there, so I'm going to delete the pi. Now I'm back to my constant rate of change. Okay, so let's interpret this. Volunteer, what's the meaning of this number, negative 0.325? Who wants to tell me what the meaning of this number is? Elizabeth, you want to do it? Okay. All right. And is that a good broad definition for it? Every minute. So is that true? Does every minute the battery percent go down 0.325%? Is that what that's saying? Is that true? Yeah, I mean, yes, you could say that for sure. I think it's just saying it just goes down at a constant rate the whole time. But yeah, for sure between those two. Okay, so is that a true statement? What she said every minute the battery percent goes down 0.325%. Is that, did I say that? Okay. Okay, so okay. Right. Okay. So yeah, so our good definition would be given any number of minutes in the class, right? The amount that the battery decreases is 0.325 times that number of minutes. Or what's a mathematical, is there, given the variables that I gave you, what's a mathematical expression for that? Anybody? Let's write out. What's a mathematical expression that embodies the meaning of that negative 0.325? Yes, I called it P. But yeah, you got it. Agree with that? You agree with that? Exactly. So this little equation frames for us, it frames the meaning of that number, the constant rate of change of negative 0.325. It means for any change in time in the class, you get that change in battery percent by multiplying by negative 0.325. Okay, cool. All right, so all right, so now I'm gonna let's do a little bit of graphing here. So to plot a point, we need what's called a 2 vector. And to get a 2 vector, you do control 2, not there though. So I need a new math line. Okay, so a new math line is control return. You don't have to remember all this. We'll do this, we'll get into this next week. You can experiment it with it this weekend if you want. A point is a 2 vector, control 2. And so what's my first correspondence point of time in percent? What's the first one? So if my time is independent, my percent is dependent, like what's the first point? Ashley. 35 minutes? 41%? Is that a correspondence point in this situation? Agree with that? Okay, and then I'll make a new one. What's the other correspondence point? I'm just writing what you guys tell me. I'm not 28, sorry. Is this right? Okay, so now I'm gonna plot those points. So now so this first one was a mathematical expression that returned a number. So this is now, we're kind of telling GC to graph points. And so as soon as we put those in, see down here in the lower right hand, it says graph. So if I graph, it opens up the axes and nothing is there. Why not? Yeah, notice the range here. It's vertically from 1 to 6, horizontally from 1 to 16. So we can't see these points. So down here in the lower left-hand corner, see this? You got zoom in and zoom out. So we want to zoom out. That's the little mountains there. And that's a good window for these points. So now it's showing in red our first point, blue our second point. Okay, so what I want to do is I want to show graphically, I'm going to show a variation in time. This is now question 3. I'm going to show a variation in time starting from 35 minutes and ending at the 75 minutes. So this is what I want GC to show. This. Something like that. But I want GC to show it a lot prettier than that. So I want to write a mathematical statement that GC will interpret as, oh, you want to show that. So what? I'm going to start a new statement here. I want everyone to think about that. Work on this by yourself. So what mathematical statement, the points are gone because I started a new line. What mathematical statement would GC interpret as, oh, you want me to show you that? So because that's what GC does. It just takes the math that you give it and it either returns a number, usually returns a number, or something, a display of something. So if we know the math of what I drew, then we give GC the math and it'll do that. So what, any thoughts? Angel, any thoughts on that?
Would you do y equals 41 and then you put domain on there between 35 and 75 for x?
Why did you say y equals 41?
Because that will produce a horizontal line.
Okay.
And then set a domain, and then
what if I hit graph right now?
that would just graph y equals 41 domain. So it'll go like all the way. It won't be between 35 and 75.
Right. So it'll show what? The entire line, right? But I just wanted to show that part of the line, so I don't know how should I? Okay. Well, mathematically, how do you set a domain mathematically? What are we saying?
Oh, is it like a bracket?
Okay. Inequality. But what do those brackets mean? Like, so it's less about the symbolism and more about what mathematically are we specifying there? What are we saying? We're saying y equals 41, but then we're saying what? Yeah. So what's the math behind that? Tell me.
Given that it has to be between 35 and 75.
So what should I type? Okay. Right. We want to make sure x is between 35 and 75. So exactly how do I write that? Is this computer code? Is this computer code? No, it's just a mathematical statement, right? It's specifying, what is it specifying? It's specifying a set of what? Points, right? It's every ordered pair such that, if it came along here, what can you tell me about that point right there? Elizabeth, what can you tell me about that point? No. Y value of 41. Yeah, it's some x value that's in that range, right? It's some value, maybe, what is this? Maybe 48? So that's what it's a set of points, right? So it's a set of ordered pairs. For every x value between 35 and 75 with a y value of 41, right? So now I've got that in there. If I hit graph, maybe, okay. There it is. So we're just telling GC the math, and it's reacting and interpreting, not interpreting, but just giving back to us the mathematics that we told it, right? So now you write, I want to show now the corresponding change in percent for that change in time. Write the next statement that'll be, give me a vertical line that shows the corresponding change in percent. Okay, she wants x equals 75. Agree with that? Some nods there. Okay.
And the inequality of 28 less than or equal to y less than or equal to 41.
Agree with that? She said then y between 28 and 41. Make it black here. Okay, is this making sense? I forgot what the last test was. Okay, so one last task. How about I want to display the set of all points for that show the set of all points that show the number of minutes the class has gone by and the corresponding battery percent. Is that what these do? Does this show different times that have gone by and the corresponding battery percent? What is this showing? This is showing a constant battery percent of 41, right? So it's just showing how much change, just the change in time from our first point to our second point. But it doesn't show the corresponding battery percents. Now I want to show that. I want to show the set of points, set of correspondence points that for every battery, for every time since class started, it shows the corresponding battery percent. To show all points that give time since class started and corresponding battery percent of your calculator. Any volunteers?
Can I volunteer?
Please.
Okay. Okay, so does Graphing Calc GC use a point slope form? Is that unacceptable?
It gives you give it the mathematics, it will put back the points.
Okay. Then have y minus 41 equals 0.37.
That thing?
All right, C5, yes. Times the quantity x minus 30. And that is
X minus what?
35. Yeah. And that's from having a domain of x greater than or equal to 0.
Okay, so before I hit graph, what do the rest of you think? Comments, reactions, what do you think? Agree? Anyone? All right, I'll hit graph and see how we did. Is that what I said? Is that the set of points given any time? It gives you the corresponding battery percent. Yeah, and I can click on here and I get crosshairs. If you notice right here, it'll give me the correspondence point wherever the crosshairs is. So what's the meaning of that point right there? Can you read it? So what's the meaning of that point? Okay, battery life will be 19.6% when 100 minutes have gone by in the class. Yeah, very good. Okay, so you can see how having students, and so this is similar to in the beginning of the calculus course, we have the calculus students creating animations like this, or little graphs like this. You really have to understand the math behind segments, lines, right? But then at the same time, it's in a real world context where that segment has, and those lines have meaning, right? This vertical segment has this meaning of how much the battery percent went down over this time period from 35 to 75 minutes.